to 2.5 inch. 1.5. 1.5 to 2.5 inch. So I will select it to 2 inch. I have 2 inch here. And I have another 2 inch here. So the remaining distance will be 12. So gamma h equal 12 inch. And your h as a distance equals 16. Can you figure out what is the value of gamma?
0.75.
0.75, that's fine. So I will select, I have many interaction diagram. I will select one for uniform distribution of reinforcement. And if C prime equal 4,000, if yield equal 60,000, and your gamma 0.75. If you don't have 0.75, you can choose one, gamma equal 0.7 or gamma equal 0.8. If you are more accurate, if you need to be more accurate, if you would like to get the exact value, okay, I will, from this diagram, I will get a row. And from this diagram, I will get another row, and I will use something in between, if you would like. But anyway, you can choose one of them, that's all.
Is one safer than the other?
Yeah.
0.7 would be safer than 0.8 if I'm looking at that one?
Maybe.
Okay.
I cannot decide which one is more safer based on what is the value of rho in each diagram. Okay, but the best scenario for gamma equal 0.7, get a value. For gamma equal 0.8, get another value. To get your accurate value, do some calculation in between for gamma equal 0.75. This is the best scenario.
Okay.
So, okay. Let's assume this is the interaction diagram we are going to use. Let's assume. So your Rn equal 0.065, 0.05, 0.06, 7, 8, 9, so 0.065 something here. And Kn equal 0.9, 0.9, 0.8, 2, 4, 6, no, 0.8, 0.9 something here, in between 0.8 and 1. So from this one, and this one, your value will be here. So we have a row for this curve, 0.01. For this curve, 0.02. You are in between maybe, so I will use row 0.015. Or 0.012, 0.013, that's fine. So your area steel divided by area gross equal 0.015. Area steel divided by 16 times 16, which is your area gross, equal 0.015. I think I can figure out what is the area steel. Once you get your area steel, what should I do else? Convert this one to number of bars by assuming maybe number 3, number 4, number 5 bars, and get your number.
Do we know how many bars we want to use?
Sorry?
How many bars? Because it said it needed to be.
Yeah, if you have uniform distribution, I think, and the two opposite side also, I think your number must be integer number. Not integer, I'm sorry, it should be integer. Even number, not odd number. Your number of bars in column must be even numbers. Even if your distribution in two sides only or uniform distribution, your number must be even number. And also, you have some rules you need to follow. Do you remember these rules? Yeah. Your percentage of steel, something in between 1 and 8%. Not less than 1, not more than 8. At least we need to have 4 longitudinal bars, at least. If your column is tied column, but if your stirrups are spiral ties, we need 6 bars. The minimum dimensions, that's fine. Yeah, for stirrups, based on what is the diameter you are using. If you are using number 10 or smaller, the size of your tie should be 3, number 3. If your diameter of longitudinal bars greater than 10, we need to use bigger stirrups, number 4. And also, yeah, that's, the distance between stirrups is not important issue. One more example, last one. Using the ACI column interaction graph, select reinforcement for the short round spiral column shown in the figure if FC prime equal F yield P ultimate M ultimate.
Spiral column.
Select reinforcing for the short round spiral. We don't know how much reinforcement we need. So, and also this column under the effect of normal axial force and moment. So axial and moment, I will use interaction diagram. What will happen if we don't have moment? What will happen if you don't have moment?
Just use.
Yeah, that's right. Just go back and use this equation. For a spiral column, your design normal force, which will be P ultimate, equal 0.85, phi, your phi for spiral column 0.75, 0.85 C prime area gross minus area steel. I can figure out what is the area steel. It's very easy. If you don't have moment, just axial force. But if you have axial and moment, no way. I have to use interaction diagram. Okay, do you think area concrete is given? And your dimension of concrete is given? Yes. Your diameter of this column is given, 20. So I can figure out what is the area gross. So I don't need to calculate area gross first. No, go ahead and put your steps for interaction diagram. Yeah.
If so, say it doesn't give you any moment.
It does. If it doesn't give you any moment, no, wait.
Oh no, I was asking.
Maybe you have B and eccentricity, because
Yeah.
eccentricity is another shape of a moment.
Okay.
Because your eccentricity equal your moment divided by P. You know what I mean?
Yeah.
To be specific, I'm sorry. Guys, I'm talking about if you have P ultimate only, nothing else. But if you have P and eccentricity is a different shape of your moment. You know what I mean? Because your eccentricity equal your moment divide B. So if I give you P and the eccentricity, that means we have moment. Okay? Okay, so for this column, what is the value of Pn? Will be P ultimate divided by phi. P ultimate 500. What is the value of phi?
0.75.
Yes. Remember, this column is spiral column, and the phi for spiral column not 0.65, it's 0.75. Mn equal M ultimate divided by phi. M ultimate 225 divided by 0.9. Then your eccentricity equal Mn divided by Pn. Eccentricity means we have a moment. Eccentricity means you have a moment. And the relation between eccentricity and P and M, this equation. So 500 divided by 0.75, 36.67. 250. So your Mn 250 divided by 666.67, your value equal 0.375 feet. Also, the total diameter is 20. The distance between this face and the opposite face is given by 15. And this one can be called gamma h. And the 20 is your h. So, gamma h is given equal 15. And your h, which here in this example is the diameter, 20. So I can figure out what is the h, equal 15 divided 20 will be 0.75. So go ahead and select interaction diagram for circular column. For circular column. And Fc prime equal 4,000, F yield equal 60,000, and the gamma equal 0.75. If you don't have something for 0.75, go ahead and use gamma equal 0.7 or gamma equal 0.8. Then, what is the value of Rn? What is the value of Kn? I think Rn equal Pn time eccentricity, Fc prime, area gross, H. Kn, Pn over Fc prime, area gross. That's right? Pn 666.67, your eccentricity 0.375, but don't forget to multiply by 12 to be in inch. Fc prime 4, KSI, area gross given 314, your h here will be your diameter 20. I think I can figure out what is the value of Rn. Pn 666.67, Fc prime 4, area growth 340. What's this value and what's this value? This one will be 0.85. This one will be
I got 0.12 for Rn.
0.12.
Yeah.
Sure?
Yeah.
Let's try.
Is it 4.5 for your E?
Yeah.
Say it again.
0.12.
0.12, yeah, that's right. So the second 1.57, 0.53. So from Rn and Kn, I can enter my interaction diagram to figure out what is the value of rho. Once you get your rho equal area steel divided by area gross, go ahead and get your area steel. Any question? Interaction diagram is a very simple method to design your column. Next week, we will talk about some requirement by ACI, requirement related to deflection, cracks, development lengths, all of this stuff. And we will figure out how to design slabs. Have a good weekend. Just hold